Hi, I'm Paul Battaglia, and this is section 7.1, Linear and Nonlinear Systems of Equations. You know, I often find that at this point in the year, my students are a little bit bogged down. We've just finished up chapter 6, and there were a lot of abstract concepts in that chapter. We've also spent a significant amount of time talking about trigonometry, and so they need somewhat of a break, so we need to jazz things up a little bit. So I'm joined today by Gabe and Brittany, and what I'm going to do just to start us off here is kind of just tease the idea of a system and show you how I would do that in my class. So what I do is I walk into class first day of this chapter with 3 envelopes. And in the envelopes, I have 3 what I call contracts, okay? And the situation I might pose to them is that we have an athlete, let's say perhaps, who is renegotiating their contract. Now, as a teacher, when you structure these contracts, you know, the idea is to make them so that they fit the mold of a system of equations. So what I need is at least 2 contracts to be equal to each other at some point. Okay? So just to give you a quick example. Let's suppose that contract 1, I'm guaranteeing the athlete, you know, $600,000, and I'll pay them, you know, $15,000 a game. Okay? Now I might go and say the second contract, I'll guarantee you $800,000, but I'll only pay you $10,000 per game, something of that nature. Okay? Again, structured such that the equations are the same at some point in the season, so to speak. Okay? Now, one thing I also might do is just kind of add a little bit of kind of mystery into it. And I might say, you know what, all right, last season, this athlete was injured, suffered a devastating injury and missed a lot of the season. So for that reason, in the third contract, I would say, maybe I'll pay you $1 million. However, we're going to subtract $20,000 for every game you miss. Okay, so very different because I'm not telling them about how much money they're guaranteed in that contract. And I'm also technically not really telling them how much money they're making per game. So a little different scenario gets the students talking for sure. And the whole while, they don't even realize that we're actually talking about systems of equations. Okay, so just a little intro activity gets them, I think, ready for some of the methods we're going to talk about. So Brittany, talk to us a little bit about the method of substitution.
All right, for my students, for at least the first few problems, I like them to take it slowly and make sure that they're really looking at their algebra so that they don't make any mistakes, since they sometimes do. And then I like them to label their steps. Because a lot of times they'll forget to do the back substitution step.
Yeah, and speaking of back substitution, I really like to put some emphasis on back substitution. They may not have heard this last step called back substitution before, so after I point that out, because really I know where we're going with this. We're eventually going to get to solving these systems using matrices. And we're going to be talking about larger systems, and the step of back substitution is going to keep coming back up over and over again throughout the next chapter or 2.
And how about the idea of, you know, using that back substitution to find that remaining coordinate? You know, I always find that students, when they're solving these systems with substitution at least, stop after that first answer and don't realize that there's another value out there to be found, you know? And then finally, one other tip we might give you is that since students may have seen this process before, maybe in an earlier algebra course, it's likely that when they were solving these systems, they were graphing, maybe even graphing them by hand. Now, at this level, I think we can encourage them to use their graphing utility, particularly as we talk about nonlinear systems. I hope these tips have been helpful for you and that you find much success in section 7.1.